All right, this is my lightning talk. My name is Andrew Fallon, and I will be talking about memory layout. So arrays are stored contiguously, just regular one-dimensional arrays are stored contiguously in memory. With each member of the array stored next to the next member of the array in the memory itself. And then multi-dimensional arrays can either be stored as an array of rows or an array of columns of data. And so row major storage is where a multidimensional array is essentially an array of rows of data. And so it's used by most programming languages. And the reason why it's used by most programming languages is that when you're accessing that array or a member of that multidimensional array from memory, it loads in the memory by chunks. And so if you load in a chunk of a row of an array, then if it's stored contiguously, then you get cache hits for not only the thing you just searched for, but the next couple elements in the array. And so this makes memory lookup for row major stored arrays much quicker than column. However, column major is still used basically just in Fortran. And so this causes slower memory lookup because every single element in a row of an array has to be looked up separately because it's not stored contiguously in memory. And so each column, quote unquote column, um, is different, and so results in no cache hits when you're looking up, all of the elements in a multi-dimensional array. And now, another way to store a multi-dimensional array is to actually make an array of pointers to each of those single-dimensional arrays. And so, what this does is it does end up making a whole separate array, and you have to allocate memory for each of those pointers, which is one reason why it's a little inefficient. But one thing that it can do is when you just have the array of pointers, then you can have different sized arrays within that single two-dimensional array. And so, what this is especially useful for is strings, which are just arrays of characters, and they can be of unequal size. And so, this allows those arrays to be exactly the size they need to be without all being of the same length. And so, that can sometimes allow for even more memory savings than you spend on the extra array of pointers. And then in terms of actually calculating the address of a member of an array, if that array's address is static and known at compile time, then it can basically do all of those memory calculations and pull in data from memory at compile time, which ends up making the runtime calculations much quicker because it doesn't have to pull from memory at the same time as it's trying to do calculations. Um, and so that's the reason to sometimes store something statically like that is to allow for greater efficiency by splitting up different tasks between compile time and runtime. But then if you're using that row pointer format where you have an array of pointers that each point to their own array, um, then it's a little more straightforward. It's basically just pointer manipulation um, to find those spots in memory. So that may also be another plus in the row pointer camp, is that it allows for easy interfacing with other pointers. And that is it.